So let's walk through what this process actually looks like for building this agent from start to finish in Go. Now, there are a couple ways that you can build a completely new agent in Go. The first, you can hit this little black button on the home screen and create a new agent either from blank, from a JSON structure, or import via a CSV file. You can also create a new agent via this plus button here, or by coming into one of these folders and hitting New Agent. Once you pop into the Hit New Agent button in any of those places, you'll get popped up with this UX. From here, you can create a new agent or browse templates that you can select from and then populate inside of the platform. In this case, we're going to create a new agent. We're going to call it Offering Memorandums Analyst. I already have a description ready to go, so I'm going to copy and paste it in there. And you can adjust the cover photo via this little tooltip there, or you can upload your own. So if I create a new agent is being created, and you'll see that we created it in the work in progress folder. I typically recommend most workspaces have a work in progress folder so you can move things from a development move into a production environment. So in this use case here, you'll see that every new agent starts with two properties, a file with a manual user input, and an AI text property with no inputs included, but just starts as your base. So to begin, we're going to start by uploading all of the offering memorandums that I'd like to test in this use case. Now, you can do this manually or you can do it programmatically. In this case, I have 3 files ready to go that are a good example of offering memorandums that our company would typically deal with when we process these. The recommendation when working with any of these files, as I said, is to start from someplace in the range of anywhere from 3 to 10 total files. You start with this small amount as you're testing and iterating because it will make sure that you minimize the amount of tokens that you are utilizing throughout the testing process. But we also recommend that these 3 to 10 files are highly inclusive of any of the most common edge cases that you see, but are also files that you know extremely well the data that you're looking to extract. This makes the QA process at the end much more straightforward when you have that ingrained knowledge already ready to go. So the first thing that we're going to do once we have these documents in here is we're going to adjust this first AI property, and we're going to then pull out the name of the property from this offering memorandum. Now, you're going to see me copy and paste the majority of my prompts in here because we've already done some of the legwork before we got into this session so that we could make sure that we weren't taking 3 hours to do this build with an explanation and having to write out each prompt individually. But I'll explain these as we go. They're all going to follow our very standard prompting format, which we are going to call RTF or role task format. You are an expert real estate analyst. This is the role. Next, we have extract the full property name from the offering memorandum. This should be the official name of the property as listed in the document. This is the task. And then down here, we have return only the property name without any additional commentary. This is the format. So this structure is really scalable. It's easy to duplicate these properties as we create new ones, or just copy and paste this property or this prompt into future properties so that you make the overall build of this agent go much faster. But for the majority of the prompts that you're going to see us lay out in here, you'll see us use this format and specifically this line in pretty much all of them. So from here, what we're going to do is set up the inputs. Now, all of these are pretty much going to look primarily at the file, but we're also going to include other properties with those inputs in the future. But for this case, we're just pulling the property name out of the file. We're going to enable AI citations, and we're going to leave the default GPT 4.1 model here. For the majority of your extraction tasks that are just pulling something out of a file or a document, GPT 4.1 is going to do the job very well 99.9% of the time. If you're looking for a more powerful model where you need to do higher levels of reasoning, we recommend utilizing some of the Gemini models, either 2.5 Pro or 2.5 Flash if you need a faster output. The Claude Opus and Claude Sonnet 4 models are both also very good. Opus has been primarily really good at coding, but for the most part, as I said, for simple extractions, GPT is going to do the job really well. So this is the general structure of everything that we are trying to build in a property in V7 Go. You have the name of the property, what type it is, the tool you're using to get the information out, whether or not you enable AI citations or a text or a number property, the input that you're then pointing this property to go back and reference, and then the prompt to tell it what to go and do. So if we jump out and click out of here, you'll see that we'll begin to understand the file and we'll find the property name inside of here. From here, as we go along, we'll just continue to do either duplicate the property and adjust the names. So next we want to pull the property address. We'll delete the previous prompt and we'll add in this new prompt to extract the complete address from here. So you'll see it follows the same format, role, task, format at the end. By duplicating the property, you take everything the same. So it's a text, it's a tool using GPT 4.1. We have citations enabled, and it points to the same input here at the file. For when you're duplicating properties, always make sure to click Save and Apply. If you click out of here into this white space, this will not save, unlike when you create a new property, clicking out into the white space actually does save that property because it's net new. So you'll see that we have the property name and the property address available here. We jump into these, we can see the AI citation to pull exactly where these came from once this document loads. And now these documents are quite large. These are someplace in the range of 60 to 100 page offering memorandums. And so when you're dealing with documents of that size, there are times, especially as I'm recording, where those documents will take a little bit longer to load. But if we look at them in review point, we can see Lund Point Apartments where it's pulling from there, and we can then pull the property address direct from that side. If we jump into the next file here, you'll see that we have Sunnybrook Business Pad sites, where we're pulling from here, and where the property address is on this side. So that's the general gist of how we would get some of these text properties in here. Next, we're going to build in a single select property so that we can identify the property type, which we'll then use to create some sub workflows in the future. So first, we'll have property type. We're using a single select property. I'm going to give the prompt in here. We're going to point it at the file. Because this is a single select, we will not have AI citations available because we're only available in text, JSON, or number. For this instance, I'm going to use 2.5 Flash just so that we can see how another model does. And I'm going to copy and paste my CSV here so that you can see what this looks like. These are going to be all the different options that I select. If you copy and paste this either from a CSV or an Excel file in a kind of formatted column, you can paste it directly into the bar there, and all of those outputs will be selected on this side. I'm going to delete this from the prompt, and I'm going to now let it run. Calculate these because we adjusted it after. And you'll see that we will quickly identify which of these property types these offering memorandums are related to. So in this case, we have multifamily, mixed use, and whatever this warehouse one is when it loads. For these single and multi-select properties, you can see the reasoning as to how they made this decision. So in this case, the document is titled Multifamily Offering Memorandum and describes Lund Point Apartments with 25 units totaling 23,760 square feet. For mixed use, you can see the reasoning here, describes the property as pad sites, and mentions a mixed use development that includes retail, office, etc., etc. So when you use multi and single select options, you can get that reasoning even if you don't have citations natively available. Next, let's do a number property so that we can identify what the asking price of this building is. We'll point this back to the file, enable AI citations, and for number properties, what you'll notice is that we have a data format input available here as well. Automatic will just return the default formatting, but you can enable custom data formatting, determine the amount of decimals and negatives that you'd like to use, as well as whether you want to use thousand separator and align all the numbers to the right. I'm going to select both of these to show you what this looks like. And when we jump out, you'll see that this will begin to calculate. Sometimes, if you see these pieces calculating, this can indicate a couple of things. Sometimes we have a rather long queue for specific model types. So if I jump in here and I switch the model type, it could go faster. Another thing that we can do is if I just refresh the page, sometimes that fixes it. In this case, it didn't. But we'll set up 4.1 here, come to the bottom, recompute all stale properties, and we'll see if that solves the issue. V7 Go is still a platform that's been around for less than a year. And so we are still working through a lot of these system updates and making sure that we're able to scale these things out purposefully. What we're seeing here now, and this is great that we went back and did this, is that you're getting a different output actually for this specific OM here that shows Sunnybrook business park sites. So let's jump into the reasoning and see why that is. Within a business park intended for office and medical office clinic development. So in this case, GPT-4 honed in on the idea that there were incentives for new office construction and references to office market data that the Gemini 2.5 model didn't. A very common thing that we will see some of our clients do is if they'd like to test and see what the efficacy of different models is, they can actually set these up using the same property with a duplicate and just switching the model. From here, we'll be able to compare and contrast what the different outputs are based on what model is producing the output. So in this case, we'll see if a new property with Gemini works quickly. We'll get multifamily here. We'll get mixed use here. And Gemini is really struggling to calculate this document. So maybe instead of Gemini, we'll switch this one to Claude. Opus. We'll recompute. And we'll see what the output looks like. Oh, it calculated right as I click that. Great. So this is a good example of how you can QA models in real time. The other thing that this would let me know is that it might make sense in some of these prompt outputs to be more specific with instructions about what classifies each of these as either residential, commercial, office, or one of the other selections that we have here. What that would look like is basically here are the definitions of each of the possible choices. Make your decision based on these definitions. And then from here, we would do residential, commercial, etc., etc. From there, the model would have more specific context and be able to determine those things a little bit more smoothly. In this case, Claude has selected land, and I think this one makes the most sense, mainly because these are all land parcels. There are no finished buildings on here. They're selling 3 individual lots, and so this might make the most sense as a land purchase. This is, again, where after this bit of initial testing and iteration, this tells us that we definitely need to go in here and apply more logic and context into the prompt so that we can give the AI more information to make its determination with the most available info. The other thing that we could do in this instance is set up these definitions inside of the Knowledge Hub documentation if we wanted to. The Knowledge Hub is where you can store all of your institutional information that you can then go back and reference inside any of these agents. So if for in this example, we had a document in the Knowledge Hub that specified all of the definitions for each of these single select properties down here, what we could do is select it from the library, choose it out of one of these options, and the AI would then use that document as context, as an input, to determine what this piece of offering memorandum was offering based on these options and that documentation in there. So we have the asking price calculated. If we jump back to there, you'll see we have 6.9 million, 3.15 million, and number of properties also have citations built in. So you can see where they're getting this information from. Offering price, 3.15 million. Great. So we've got a lot of the basis and the bones built into here. Let's keep going, building out some additional pieces. This is going to go a little bit faster now that we've explained the majority of the workflows that we're going through, but let's continue. So we're looking for total square footage. We're going to keep the custom breakdown. We're going to save and apply. One thing to note with number properties is that they will always come with this denomination at the end for determining what the breakdown is. It's important that you very clearly express it inside of the prompts, what you want this breakdown to look like. So in this instance, the total square footage is 94,635, 23,760, 66,430. Next, what we're also going to do is build in some additional logic to get the price per square footage into here. Now, this is an instance where you could come in and utilize Python and basically do a simple calculation of the asking price divided by the total square footage so that you could get the price per square footage. What we're looking at here, though, is that I know, because I know these SIMs or these OMs really well, like the back of my hand, I know that the price per square footage is included in the SIM. And I want to be able to accurately use a citation to identify where that number is coming from inside of the document itself. So I'm going to say, you're a real estate analyst expert, extract the total price per square footage of the property from the offering memorandum, return only the numeric value without any units or formatting. If multiple figures are provided, extract the gross square footage. But we're going to say price per gross square footage. Now we're going to save and apply. AI citations are on here. If we were to utilize Python in this instance, we would not have the AI citations available. Now, what we're going to see here is these numbers start to populate. And if we come into one of these and break it down, open citations, we'll find exactly where this is coming from. And I chose the bad example that doesn't want to show us citations. So let's check to this one. Price per square footage, 7.25. Price per square footage. You'll see that in this instance, there are multiple prices per square footage. And so this is a good example of a potential edge case where we might want to come and adjust this workflow slightly. I'm going to leave it the same as it is in here, but for the purposes of this demo, to show you what we could do as a next step, knowing that we have multiple lots available in one offering memorandum, there might come a time where we'd like to quantify the individual lots themselves. What we could do is pull up a collection and create that collection and have it say lot info. From there, we could then gather each of the different pieces of information for the lots themselves. So instead of having this asking price, total square footage, and price per square footage exist in this main workflow, we would have a collection where I'm going to say very simply, extract all the critical information for each lot in this offering memorandum. And we're going to say lot name, asking price, total square footage, price per square footage. Great. We are going to let this now calculate with a very simple prompt. Adjust that name. And let's see if it's able to pull it. It looks like for this one we did. And it looks like similarly here, there are multiple lots available with each of their breakdowns. So if we click into the top, you'll see that we have multiple properties in this OM with different layers of square footage and different prices per square footage included as well. So this tells us that as we're working through this workflow and all of these offering memorandums, I need to be very aware that there are going to be instances where these offering memorandums have multiple lots included, and they're all going to have different pieces of info related to them. So in this example, this multifamily offering memorandum only has one lot that they're selling. It's the entire Lund Point Apartments, and so we get the correct info from here. In these other instances, such as the Sonybrook Institute and the Greens Retail Warehouse, there are multiple lots included with different delineations for their square footage and their price per square footage, as well as their asking price. In this example, we'll see that we got the individual pieces here, and what the AI did on this level is summarize all of them. But in this case, the top one, it only took the first asking price, the total square footage, and the price per square footage from the first instance here, missing out on all these other pieces. So this tells me that for this workflow moving forward, I'm going to want to have collections to set up anything where I might need to delineate between the different lots available. And this is something that you learn as you kind of work through the process of building in Go and how all of this comes together. This is also going to account for certain edge cases. So in this instance, I might be able to say for any retail, office, or land property, I need to create a collection instead of having these individual breakdowns, because retail and land or office properties will typically have more than one lot available in them in an offering memorandum. So from here, I would set up a sub workflow and say retail. And for any of these retail offerings, I would need to come in and have a collection to break down the lots and the asking price total square footage. But for a multifamily, a residential single family, I wouldn't need to do that because more often they only have one lot. So this is a good example of how you would come in and have sub workflows built into your main agent this way. Great. So we're going to leave that as is and continue to work through the remainder of the workflow. We want to understand what year that this property was built in, if there's information in there. If there is no mention of the year this property was built or the most recent renovation took place, return not found. So that's another important one to account for edge cases. There will be some instances where the AI is not able to determine or the information is not present inside of the files themselves. In those instances, the platform will default to providing not applicable, but it will not be a default value like this. If we want to have an actual AI output value inside of here, it's important to dictate that inside of the prompt itself and be very specific about what that output should look like moving forward. So in this case, we want not found if we can't identify what year this was built in. Going forward, we want to also identify the last renovation year. And in this instance, I want to keep the same structure, put in the new prompt. And you'll see here, if no renovation is mentioned, returned none. And what we're going to do, no renovation is mentioned, return not found. Save and apply. Great. Moving on to the lot size. Now this process becomes very quick rather, if you do some of this upfront work ahead of time, because we can determine and just kind of pop in here and copy and paste the prompts very simply. Because this is going to be a rate, we most likely will not need 1,000 separator, but I always like putting it in there just in case. If we want, we can also increase the amount of decimal points. Because this is a percentage, I want to have at least one decimal point built into the occupancy rate side there. We're also going to want to know things like the current NOI, but this isn't going to be relevant for every single property here, but it might. So let's put it in the main workflow. Also going to have the cap rate. No number found in this current NOI. So in this instance, something that we'll get into in the future is certain files will come back without key information that we need, whether they're unable to be found or whether it's just not present inside of the file themselves. In this instance, we'll set up a single select property that we'll call data validation, and we'll do this at the end. The input for all of those data validation pieces will be these previous properties, and we're going to ask the AI to identify any of the properties that don't have the critical information present in them. From there, we will send those properties or those entities into a separate workflow for human review. From there, we'll have a human in the loop who's able to determine whether or not these pieces of information are actually not present in the document through a kind of manual search, or if we can pick it up from other spots inside of the workflow. We're going to get into a collection now, and it's going to occur around tenant information. Now, in the prompting structure for a collection, we're going to give it all of the pieces of information that we want, and that's going to be tenant name, leased area, lease expiration date, annual rent. We're asking it to format this collection with these properties. If it's not available, return not available where relevant. The instance of using a collection in this use case is that we're not going to be able to use citations here. I am going to turn on GPT or Gemini 2.5 Pro. And once this is done, we'll jump into the collection and we can walk through how you would kind of take this to the next step as an additional sub workflow. While it loads, we're going to build a multi-select that's going to show property condition. We're going to ask the AI to identify all of the different pieces in here using GPT 4.1 to the condition of the home. Because all of these are potentially overlapping, or some of them are potentially overlapping, we're using a single select here. The other way that you could do this is we could take these top 3 and add poor condition or terrible condition even, and set this up as a single select property, adjust the prompt to say, give me an understanding of the general condition of the home as excellent, good, average, poor, critical, something like that. In this case, we're going to keep the multi-select. No match found. If no match found, keep empty. So the other thing that we can set up here is if the AI is unable to determine a match, we can then set up where it should go, whether to keep it empty or not. From here, we're going to want to add either other or none properties, recompute, and we'll see what this comes back as. This is another instance of iteration where it might make sense for us to go in and adjust which model is doing this to a higher reasoning model to see if we can get a better output. So we'll use Gemini 2.5 Pro and we'll see what that is. In this instance, we have the tenant information ready to go. So let's jump into there. We don't have the tenant name available for any of these. We do have the lease square foot, the lease expiration date, and the annual rent for these spots. So this would definitely trigger a manual review. Let's jump into another one of these. Right here, we actually do have some information about the tenant overview and what they own, what their square footage is, when it's expiring, and how much they pay. So this is a good example of when these collections work accurately. The issue is that you'll see these all come up with manual inputs. No citations are available inside of these collections at this time. We are working on expanding the functionality of the platform to include citations for collections, but at the moment, not available. What you can do, however, is set up additional properties inside of this workflow. And they can be any of the properties you can set up at the top level. And if we were to select text or number, you'll see that AI citations are available here when pointing back at the file. So if you like to add on information into one of these sub workflows, it's possible. In this case, we're not going to dive too far into that for this setup. You'll see that now that we've used a higher reasoning model, you've gotten some different pieces of output in these. Let's look at the reasoning as to how they came up with these things. Property as a turnkey asset, no deferred maintenance, indicating is in an excellent condition. It has numerous recent improvements, such as new flooring, cabinets, etc. The document, however, explicitly states that the estimated life remaining on the roof is 5 years, which constitutes a roof issue for a potential buyer to consider, which is why they had roof issues, why they've set it as recently renovated, and in excellent condition. If we jump into the none, the provided document is an offering memorandum for vacant pad sites, not for existing buildings. Therefore, there's no mention of property condition or any of the other items that we've listed inside of this multi-select. So it did a good job of selecting it there. And because they're all just vacant land pads, you get an empty collection because there's no tenants present. Next, let's get into a zoning classification. And you could do this a couple of different ways. For now, I don't have a discrete list of all of the different zones that this could potentially go up to. So we're just going to extract it in the text property using an AI citation and see what we get. The next piece that we're going to do is get a market analysis summary. And so everything up to this point was a very basic extraction. There has been little reasoning needed to go over it, except for maybe the property condition piece. But in this next one, we're going to be looking for some pretty specific summaries, which is going to take a little bit of analysis for the AI to complete. In this instance, we typically recommend that you use one of the reasoning models. For here, I'm going to use Gemini 2.5 Pro. This prompting also requires a little bit more context, and we'll see what that looks like here. So you're an expert real estate analyst. This still uses the same role format. Review the offering memorandum and provide a concise summary of the market analysis section, maximum 300 words. So this kind of plays into the formatting a little bit ahead of the task. We're still asking it to provide a summary of a market analysis, which is the task, but down here, we're going to give it more context. We want to focus on key market trends, comparable sales, demographic info, and growth projections. We want to highlight factors that would impact the property's value and investment potential. So if we jump out, let's see what this comes up with. And we will actually jump into one of these once it opens so that you can see what the breakdown looks like inside of our review panel. Gemini 2.5 Pro has the longest context window of any of the available models, and so it will typically take the longest to load because it's working through multiple reasoning steps at once. As it's doing that, I'm going to continue to build out some of these next properties so that we keep this moving along. In this case, we're going to ask it to find some investment highlights, and I know the type of highlights that my firm typically needs to analyze, so I'm going to have them as discrete values there. I should select an input. That's very important. And let's use 2.5 Flash. Great. The market analysis summary is good to go. So we'll see that we get this entire big breakdown. The property is situated in a dense Beaumont, Texas. If we open citations, we'll see what this looks like here. When we have this more reasoning heavy prompt, you'll see that we have multiple layers of citations built into each of these. And it's doing this because it's pulling the information from different pieces in the document and then summarizing them into critical spots here. So we're getting a location description because we asked it to pull up location info. We asked it to find major sites that it was around, understand what the demographics are. So it pulled that information here, what the significant growth factors are and investment potential, as well as analysis of rent comparables and sales comparables through this model. So you can see exactly where it's pulling all this information from. If we want to look at this more side by side, we can come into the expand entity view here, jump down to the market analysis summary on this side, and kind of look at it side by side with all the other properties available in this view as well. Let's click out of that and go back into our next steps. We see the investment highlights is done, and it's pulled all the key investment highlights that I'd like to look at for all of these pieces. This tells me that we definitely need to have a stronger prompt setup here because this has no tenants, so we should not have a strong tenant mix, unless it's saying that no tenants is good in its explanation. And that would be something that makes sense. But it doesn't. So this is an indication of where we need to further adjust that prompt structure in our iteration process. But for now, let's keep rolling through the build piece so that we can highlight what a good workflow looks like for an offering memorandum use case. So we have the risk factors now. Let's give it to 2.5 Pro. Yeah, let's do this one to 2.5 Pro as well and see how that does with the updated reasoning. Flash didn't do it good enough for us in this instance. Next, let's put all the financial projections into a collection because this is information that we're going to want to view in a tabular setup going forward, and it'll be easier to review in our review section or our entity review section going forward if we have this set up to be a collection. So we are going to extract the following properties: the year, the projected revenue, the operating revenue, operating expenses, NOI, and cash flow. Format this as a collection of objects of these properties. We could do this in a JSON as well. I'm going to show you what that looks like after we give this a chance to calculate. There were no risk factors found. Because we didn't put any risks here. So you'll see that when we select a multi-select or a single select property, if you don't put any values down here, it'll just keep it empty. So let's put in some of those values so that we can more accurately calculate this piece. Financial projections here. We're able to see that this top layer had it. These bottom layers do not have it. And so that will require further updates from us. Let's switch the model to 2.5 Pro, recompute, and see what we have. This financial projections will be another piece that we build into that data validation single select workflow to determine whether or not this thing will need human review or not. But first, let's go into the financial projections piece here and build it as a JSON. So another way that we commonly see clients build in the platform is using this auto property. Now, we could use that and paste in the prompt that we have, save and pre-create property, and we'll see what this is. Because I've asked it to do it as a JSON, it's come back with a perfect prompt output for these financial projections. We're going to escape. If we were to build this as just a JSON and input this property here, we'll see that there will be a slightly different output. So JSONs also have their AI citations functionality built in, just like a text and a number property does. It just will populate slightly differently. Using 2.5 Pro, we got a better answer up here. And it's telling me that these offering memorandums don't have all the critical information that we would typically want to see for one of our outputs. Because I didn't define the JSON schema here, it was not able to appropriately pull in what I wanted. You'll see that sometimes the prompt is great at doing it, but let's now take what it's gotten here and add it to our example prompt. Please provide your response in the following example JSON output schema. It will look like that. Now, if we recompute, we should start to see all of these properties populate with that schema built in. While it does that, I'm going to create another collection for comparable properties. And we're going to want to know all of these pieces. Rate, file, 2.5 Pro, let it go. So we'll see here that this came back with the correct schema. This is still calculating. We must not have any of the financial projections available here, as it's an empty collection and an empty JSON. Rename that. So this is pulling through accurately. If we click on the citations here, you'll see that we'll have a citation for each entity schema that it's pulling on this side. And because they're all pulling from the same place, they're not going to a different spot in the document, but you get the gist as to where it's pulling from each of these files. Great. So this is pulled through comparable properties. This bottom offering memorandum that we have here is frankly really bad for everything that we're trying to pull through. Not having any of the comparable things that we want to see, but the first two are pretty solid so far. So we'll see that we have gotten these comparable properties with appropriate sale dates, sale price, square footage, and the price per square footage. One sec. Don't know why I was doing that. Refresh, then we got fixed. And so here we have the kind of final output for the comparable properties. Now, what we'd like to do is start to get some of those reasoning prompts built into here. And so what we're going to start with is the ROI potential of this piece. And we're going to do a single select. We are an expert financial real estate analyst based on all the provided information about this property. And we're going to select more things beyond just the file. In this case, we're going to look at the current NOI, the pro forma NOI, the cap rate, the risk factors, and the investment highlights section. We're going to ask it to look at all of these pieces, assess the overall ROI potential of this investment, consider the returns, the growth, etc. Select the most appropriate ROI potential category from the options. Now, at my firm, we calculate the potential ROI into the following categories: excellent, good, average, below average, and poor. So now that we're looking at all these inputs, we'll do ROI potential, and I want a high reasoning model. So use Gemini 2.5 Pro, please. And from here, based on all of the previous outputs that we've had, this ROI potential will examine them along with the document and provide us an output of the potential ROI. Now, in this instance, it might make a lot of sense for us to go in and classify the different breakdowns of what constitutes an excellent, good, average, below average, or poor investment. But for now, we're just going to let Gemini 2.5 Pro determine what it thinks those investments are based on its reasoning standards. So we'll see that this first one was projected as good. Let's see why. The property demonstrates strong investment potential with 100% occupancy, recent renovations, and clear value add opportunity through raising below market rents. The ROI potential is tempered by a significant upcoming CapEx expenditure and a 9-year regulatory compliance period from a tax agreement, making this good rather than excellent. Once these other two will load, we'll check out what those look like as well. But next, what we're going to have it do is create us an investment recommendation as well. And this will basically take that ROI potential a step further. And we're going to look at the document. We're going to look at the ROI potential, the risk factors, the highlights, the market analysis summary, the property condition, and have it analyze all of these to determine whether or not we should have a strong buy, hold, sell, or strong sell. Let's color code these again as well. Give me 2.5 Pro and recompute all stale fields. Now, one thing that you'll notice, because we're pointing back at previous properties, these will only load and begin to calculate if all of the previous properties that we've selected, which you can see here are highlighted in blue when you click over that property, have been calculated and filled out. Until all of the upstream properties have been completed, none of the downstream items will calculate. So in this instance, let me refresh my page and see if that has fixed it. Probably not. You might need to adjust the model. Let's put it on Claude 4 Opus with high reasoning and see what we spit out. From here, when these recalculate, you'll see that anything downstream from these properties will appear as stale if we give this a minute. So this little yellow button will pop up and tell us that this buy needs to be recalculated because one of the upstream properties was changed. Now, let's kind of bring it all home with the final output that we're looking for, which is this executive summary, if I could spell, that breaks down everything that we've looked at to this point and gives us a very concise understanding of all of the critical pieces of information that we need to know in order to ascertain whether or not we want to invest in this piece of property. So we have the cap rate, the ROI potential is next, the investment recommendation, as well as the investment highlights, which we'll search for. The risk factors, and we're missing one piece in here that I like to include, a market analysis summary, and let's also include the property condition. They're asking me to format this as a professional summary that would appear at the beginning of an investment report. Use 2.5 Pro. And let's see what we get here. So you'll see here that we have ROI potential, the investment recommendations now here. Let's see why this one was a strong buy. It is 100% occupied, priced significantly below comparable sales on a per square foot basis. The primary appeal is the substantial value add op, as current average rents are less than half the market rate, presenting a clear path to dramatically increase net operating income. Now you'll see that we have this executive summary nicely formatted. If I want to pop open the entity details view and scroll down here to the bottom, let's check out this executive summary. So we have this property with the retail location, the type, the asking price, the current NOI, and the cap rate. This summary outlines the investment opportunity for this place. We have a breakdown of the market positions and strength, a value add opportunity and ROI potential, risks and mitigants, and a recommendation of strong buy, with an explanation of why it's given that recommendation. So this is how you would go about building a V7 Go agent from the kind of inception to almost finished part. From here, the next steps are going to be to go in and QA these agents, determine whether or not the outputs that you're looking for meet the standards that you're trying to achieve with this extraction or development agent, and whether this final output lives up to what you're looking to get out of here. As next steps, if things are not meeting your standards, you would go through and iterate on a prompt level, on a property type level, and by switching up maybe some of the models that you're utilizing inside of these prompts and comparing the outputs as we did here at the beginning. As always, V7 Go and the building process is very iterative. It takes multiple steps to get to the final result. We like to say that with this initial output and this very little iteration process, you should receive about 80% of the completed value ready to go. With some iteration and slight adjustment, we expect you to get 95% of the way there. And with solid prompting updates and a very clear understanding of the formatting and outputs that you're expecting, we'd expect you to get to that final 99 to 100% pretty quickly. All in all, pretty good process to get something like this developed. Took about 45 minutes with explanations because the prompts were done ahead of time. But good luck building in Go. If you have any questions, please reach out to the team and somebody will be more than happy to assist you and maybe even help you build some stuff yourself. Thanks.